This is section 6.7. We're still talking about inverse relations and functions, but this is part 2. We're going to start talking more about graphing here. And you're going to be asked to graph equations or graph functions and find their inverses and graph them as well. Okay? So as we look at this here, our objective here is to find the inverse of a relation or a function from a graph. Okay? So some steps I've kind of put together here to kind of give you an idea of what to do on graphing on these. First thing you want to look at here is we want to try and create a table of values for the equation that's given. Usually I'll use between -2 and +2, but it depends on the equation. For example, you have some square roots, you can't have negatives, so your values are going to change, and you're going to see that as examples as we go through. Once we find those points, then we're just going to plot the points that are given to create the graph. Okay? Once you find the ordered pairs, to find the inverse, it's going to be easy. All you do is flip the ordered pairs. So the whole key is to figure out the ordered pairs. Again, once you found the table, then you can switch the x and y values and now plot the points of the inverse and create the graph. Once you've finished, you will see that the inverse is a reflection over the line y equals x. And we talked about that a little bit in our last part 1 about how it's a reflection over the line y equals x. If I reflected over that line, if I were to fold that paper over, it would fold over exactly onto that other graph. Okay? All right, so let's take a look here now at examples. Let's take a look at this first example. Graph the equation y equals x squared plus 1 and its inverse. Okay, so first thing I'm going to do here is I'm going to create an xy table. And I'm going to put in -2, -1, 0, 1, and 2 for x. Now, I'm not going to do this on every single one of these for the sake of time here, but I'll do it for the first one. So when I put -2 in, I've got -2 squared plus 1. -2 squared is 4, plus 1 is 5. So when I put -2 in, I get a 5 out. When I put -1 in, now I'm just going to go ahead and list these. When I put a -1 in, -1 squared here, -1 squared is 1, plus 1 is 2. When I put a 0 in, this is 0 squared plus 1, which is just 1. Put a 1 in, you get 2, and if you put a 2 in, you get 5 out. Okay, so now what I'm going to do is I'm going to go plot these ordered pairs. This is, again, this is the equation y equals x squared plus 1. So I'm going to go left 2, and I'm going to go up 5, which is about right in here. Okay, left 1, and I'm going to go up 2, 0 up 1, right 1 up 2, right 2, and up 5. And now I have the graph of the line, or the curve y equals x squared plus 1. Okay, now to find the inverse, okay, the inverse is just going to take these x and y values and flip them. So my x's become y's and my y's become x's. So now my x's are going to be 5, 2, 1, 2, and 5. And my y values are now going to be -2, -1, 0, 1, and 2. And I'm going to plot those ordered pairs. That's going to be the graph of my inverse. Okay? So I'm going to go right 5 and down 2. Right 2, down 1. Right 1, 0. Right 2, up 1. And right 5, up 2. Now, this graph isn't going to necessarily, right now it looks like it's a little bit narrower just because you'll notice the squares on each one of these. Each one of these squares is not a perfect square, it's more like a rectangle. That's why it doesn't look like it. Now, when it talks about being able to reflect it over the line y equals x, the line y equals x is right here. Okay, if I were to plot the line y equals x, it would look like so. As I go through and draw this here, there's a line y equals x, the red line. If you were to take and flip this over, like if you were to fold the paper in half diagonally, the black graph would go exactly on top of the blue graph, or vice versa. The blue graph would go exactly on top of the black graph. Okay? So that's the inverse in terms of the graphs. All right, let's take a look at another example here. Okay, example 2. Okay, this one here, again, as we look at this here, and you know, I'm going to skip this one. Let's go to example 3 here. What I'm going to want you to do is I'm going to want to see if you can do example 2 for class tomorrow. Okay, so see if you can do example 2 once we get done with 1 and 3. All right, now there is a reason I did this one instead. Okay, so example 3, we've got the graph of y equals the square root of x minus 3. So again, I'm going to create an xy table. Okay, now if I put in -2, -1, 0, 1, and 2, if you look underneath the square root, you end up getting a negative number. Can you have a negative number underneath the square root? No. So I'm going to start at 3, 4, and 5. Okay? Those are my ordered pairs I'm going to put in. Now, matter of fact, I'm going to change that here a little bit. I'm going to go 3, 4, and I'm not going to go 5 because I don't know what the square root of 2 would be, but I do know what the square root of 4 would be. So I'm going to go with the ordered pair of 7. Okay? So if I plug in 3, I get y equals the square root of 3 minus 3, which is the square root of 0, which is just 0. If I put in 4, 4 minus 3 is 1, square root of 1 is 1. If I put in 7, I get 7 minus 3 is 4, and the square root of 4 is 2. Okay, so that's the function. So I'm going to graph this. Write 3, 0. Write 4 up 1, and write 7 up 2. Okay, so there's the graph of y equals the square root of x minus 3. Now, the inverse. Okay, the inverse, again, I'm going to take my x's and my y's and I'm going to flip them. So this is going to be 0, 1, and 2. And this is going to be 3, 4, and 7. So now to plot these, I go right 2 and I go up 7 right there. I go right 1 and I go up 4 right there. And then I go 0 and I go up 3. So I kind of plotted those a little bit backwards, but it'll be okay. And then I draw my curve. And you'll notice again, it's the same curve as the black one, except for now, again, if I draw the line y equals x, a slope of 1 over 1, this gives you a little bit better indication of, because this graph isn't nearly as skewed as the last one I gave you. There's the line y equals x. And again, if you were to fold the paper over diagonally over that line, you would fold it right on top of that graph. Okay? So that's the inverse. So now you can tell, you're able to graph both from an equation and you're able to graph its inverse. Now, this concludes part 2. Okay? Again, don't forget, I want you to do the second question on your own and see if you can do that graph and its inverse for class tomorrow. Okay? And then we'll check it when you come back in. All right, this concludes section 6-7, part 2, graphing inverses.